Alright, this is problem number 3 in our review series of sequences and other related topics. So we're going to start off with given a set of numbers a, 2a, 3a, up to na, and hopefully you would recognize that as being arithmetic because it keeps going up by another a. So a, 2a, 3a, etc. The common difference d is equal to a. Alright, so it says in the first part, show that the expression for the mean, well, you know that the mean would be the sum of all the numbers over the number of numbers, which is n. In general, the mean, the average, is the sum of all the data divided by the number of numbers. So the sum, we can use the arithmetic sum formula, which is n over 2, and then the first term plus the last term. And of course the number of numbers is n. So n is n over 2. The first term in this sequence is a. Now what's the last term? Well, it's na, because that was given. Everything was given here over n. So all you have to do really is clean this thing up. Let's see, the easiest way to do that, I'm going to multiply numerator and denominator by 2, I think, to get that fraction out of there. So I've got n times a, I'm distributing, plus n squared a over 2n. Okay, now I've got an n in every term, so I'm going to divide through numerator and denominator by n. I get a plus na over 2. And to get their answer, I'm going to factor out the a and get a times 1 plus n. Whoops, a times 1 plus n. I'll fix that in a second. Over 2. So that's a times n plus 1 over 2. So this is an expression for the mean of that sequence. Part 2. Let a equal 4. Find the minimum value of n for which the sum of these numbers, the sum of the numbers, exceeds the mean. So you want the sum to exceed the mean, and you want that to be more than 100. So that's what we're after here. We want to take the sum of the sequence, subtract the mean of the sequence, and we want that greater than 100. So we're trying to find the value of n, or in other words, the number of numbers it's going to take in order for that to be true. Well, now that we know a is 4, the sum, we're going to use the sum formula one more time. So n over 2. First term is going to be 4. That's a. The last term, if you look back at the original, the last term is na, so that would be 4n. Now the mean, we just calculated that. That was a times n plus 1 over 2 from the first part. And we're going to replace our a with 4, so it's 4 times n plus 1 over 2, and that has to be bigger than 100. So the sum of all the terms, we just use the sum formula, plugged in the first term being 4, the last term being 4n. We're subtracting the mean, which we found in the first part, and all we did was replace a with 4. Alright, at this point in time, all we have to do is solve this equation. I'm going to multiply both sides by 2 and distribute. So in the first part of it, n times 4 is going to give me 4n plus 4n squared. I've multiplied through by 2, remember. Minus 4n minus 4, don't make that beginner mistake, is greater than 200. So what do I got? I got 4n squares, and then minus 4n plus 4n, that goes away. Minus 4 is greater than 200. Why don't I divide through by 4 and get n squared minus 1 is greater than 50. So n squared is greater than 51. And I think what value of n is going to be greater than 51 when I square it? Well, 7 squared is 49. So n, being a whole number, has to be 8. So n would equal 8. So it would take 8 terms in order for the sum to exceed the mean by more than 100. The answer is 8. Alright, this part B is a little weird, but it's doable. There was a typo in the original problem I noticed, which made it more confusing. They had stuck an extra y in here, so I took it out. There should be not that. That y1 was in there twice, which it shouldn't have been. So let me explain what we have here. We have two sequences. The first one is called x1, or x sub I, and it says it goes from x sub 1 to x sub m, which means there's m terms. So let me write that down. Now it also says over here that every x sub I is equal to 0. So that means that every term is 0. 0, 0. Whoops, it scrolled down. Here we go. 0, 0, 0, 0. And you have the last term is 0. Now that's the set x sub I. Now how many of those zeros are there? Well, there's m of them. There's m terms. And then the other set is y sub I, and that goes from 1 to n right there, and every y sub I is equal to 1. So this sequence goes like this: y sub I, it goes 1, 1, 1, 1, etc. up to the last term is 1, and you have n terms of those. You don't know how many you just have n ones, and you have m zeros. Okay, now that we've got that straightened out, it's going to make this problem a little bit easier. It says show that the mean of this set m, capital M, stands for both sets put together. Okay, so we take set x sub I, set y sub I, put them together, and that's set capital M. So show that the mean of this set is given by n over m plus n. Well, okay, so let's make this simple. The mean is the sum of all the terms divided by the number of terms, as we did in the earlier part. Okay, so the number of terms, that's pretty easy, because in the x group there's m terms, and in the y group there's n terms, so the total number of terms is going to be m plus n. Now what's going to be the sum of the terms? Well, the sum of all the x's is going to be 0. 0 plus 0, it doesn't matter how many there are. The sum of all the y's, well, it's going to be, each one is 1, so it just depends on how many terms there are. So if there were 2 ones, the sum would be 2. If there were 3 ones, it'd be 3, etc. So if there's 10 ones, the sum would be 10. So the sum of those terms, since they're all 1, will be equal to n. So the sum of the terms, when we put x and y together, is n, and the total number of terms is going to be m plus n. And there we go. That's the mean, capital M. Okay, so that part of Roman numeral I is done. Now we have to show what the standard deviation is. Well, they've given us the answer here, and we have to prove it. Well, the standard deviation, I'm going to use the formula where you square, it's the sum of the x, sum of x squareds, and then the sum of the y squareds, and then subtract the mean squares. The mean squared, which we already know. We already know the mean. So we have to divide this over here by m plus n to get those sums. The sum of the group x squared and the sum of the group y squared. Alright, now the sum of the x's is going to be 0 again. That part's easy. Okay, so that's 0. What's the sum of all the ones? Well, if you square the ones, if you square each one, it's still 1, so the sum of that group is still n over m plus n. To find that mean, we divide by the number of numbers. And then the mean we found in the other part was n over m plus n. So we square that, and we'll square this. Because we're squaring that mean, we're squaring the whole thing. So we end up with, now we can get a common denominator here. So let me multiply the first fraction, get that off there. Take the first fraction times m plus n on the top, so it's m plus n times n. On the bottom we have m plus n times m plus n. The second fraction already has that common denominator, m plus n squared. So when I subtract those two, the common denominator is going to be m plus n squared. The numerator, distributing here, I get m n plus n squared. And then I subtract n squared, so the only thing I'm left with is m n. Now what is that? That's the variance. Remember, that's the formula for the variance. So the standard deviation is going to equal the square root of that. So the standard deviation is equal to the square root of m n over m plus n quantity squared. So the square root of mn goes on the top, and the square root of m plus n squared is m plus n. So this is our standard deviation, which they wanted us to prove from part 1. That is probably the most confusing part of this problem. The last part is not too bad. Let me get this off of there. Okay. So here's our standard deviation. Now they called it S, so let me label that as S and take out that sigma. So S, the standard deviation, is that. And from the other part, we knew that the mean, which we proved, was equal to, stop that. My pen is acting up here. Here we go. The mean is equal to n over m plus n. Now for the last part, they said given that m equals S, so in other words, the mean equals the standard deviation, find the value of the median. Well, since those two things are given as equal, let's set them equal to each other and see what happens here. So I want to find some relationship between m and n, because you can't find the median, you cannot find the middle unless you know the number of terms. So I need to find the number of terms of, remember that from the very, very beginning, the number of terms of the x group was m, and the number of terms in the y group is n, so I need to find some sort of relationship between those so we can find the median. So we're using the fact that the mean is equal to the standard deviation, which gives us this little equation here. What I'm going to do at this point is, I think I'll just divide both sides by m plus n, or multiply both sides by m plus n rather, and that will cancel. So I end up with n equals the square root of m n. At this point, I'm going to square both sides to get n squared equals m n. And then I'm going to divide both sides by n, and I get n equals m, which means that the number of x's and the number of y's is the same. N is equal to m. So since they are the same amount, the median will be the last. Remember, the x's go 0, 0, 0, 0, 0, whatever, up to n zeros, or was it, or the x's m's or n's? I gotta look back again. Yeah, the x's were m, so we have m x's from here to here, and then we have ones. The group y was ones, and we have n y's, but now we know those two are the same, dot 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 1. So since m is equal to n, then the median has to be the average of the two in the middle. Well, the two terms in the middle are 0 plus 1, so the median is equal to 0 plus 1 over 2, which is 1/2. And that is done. Well, this problem was a little abstract, a little confusing, but if you kind of sketch it out like I did, showing the zeros and the ones, it makes sense. It's not that bad. But finally, this one is done.